Hello, everyone. We're going to be doing our best to create and train a machine learning model in Microsoft Fabric. This is going to be a real live demo of this. I'm going to dive right in and see how far we can get through this process. That's me. Just as a quick reminder of where we've been so far, our first session a few months ago was bringing data into Fabric. The next session was cleaning and starting to model that data in Fabric. And all of that has culminated in us having some data in Fabric ready to go to train our machine learning model. The agenda, I'm going to skip what is Fabric today. If you need to know what that is, you can probably watch session 1 or session 2 again. I'm probably going to skip most of the quick recap. I might show some of the data that we set up in session 1 and 2. So we have more time to create and train the model, and hopefully with some time we can use that model to run some predictions. Again, today we are actually sitting in the data science bucket with machine learning, this section right here. And with that, it is demo time. And given how much code is usually written to do something like this, I am going to be copy and pasting code into notebooks as I start to build this model and train this model and then later run predictions on the model. Some of the code, I will do my best to explain it clearly. If there's pieces of the code that you're looking at and saying, I have no idea what this does, and you either want to ask the question, what does that do? Or you want me to answer some questions after the fact through chat to lay out exactly what every line of code does, I'm happy to do that. So again, shout at me or whatever you want to do to get my attention there. If anyone remembers what we did do, initially we brought data into Fabric, either using loading a CSV file direct in, either through pulling it from a notebook or reading it from a SQL server. And that's what the data looked like initially there. Then we did some cleaning of that data. Essentially, the cleaning of the data was really to, if you go back to something like this, sorry, let's go with this one. You'll notice that total charges was a string, and it's probably not supposed to be a string. It should be a number there. There's other things like senior citizen. We wanted to flip back into a string because we wanted it to be a category, and we'll dive into that in a little bit. And so some of that stuff we cleaned up there with this, getting it into this silver layer. So that's what we did during steps 1 and steps 2. And now we are taking a giant leap into step 3. So with that, I'm going to dive right in and we are going to create a machine learning model. So new item up here, come in here, you can scroll through and find it, but type ML, you'll get a machine learning model. So we're going to create our machine learning model. And we are going to, we're going to name this one ML churn. And does it, why is it not? There we go. I had a space in there. So we're going to create our machine learning model. It's going to be called ML churn. What we are going to be doing is we're going to be predicting based off of the data we have. We're going to be predicting whether a customer is going to churn or not, whether we're going to lose that customer or not. And once we create our machine learning model, it gives us a whole bunch of stuff. We can use an existing ML model. We can use an existing notebook. We can use a template. We can use a new notebook. We can start with this thing called AutoML, which may be a cool one to show in another, where it actually looks at the data and creates a machine learning model for you. But in this case, we're going to go from scratch, or we're going to do our best to go from scratch. And so it's creating a nice new notebook for us. You could potentially use some of this built-in code to start this process. I'm just going to go from scratch here again. Add our lakehouse, and we're going to add that Academy lakehouse that we've been working off of for the last few sessions. And we're going to use our somewhat cleaned data. We're going to have to do a few additional steps to it just to make sure it's as clean as possible. We're just going to dump it in here. So this is just reading out that table into a data frame for us. And quickly, I'm just going to convert this into a different type of data frame, a pandas data frame, which is a different kind of data structure. It's essentially just a table. And the nice thing about pandas is it's recognized by most machine learning libraries. We actually want to display pandas df. We can just cancel that and run that again. And if all works well, we're going to actually see our initial data. And so you can see here, this is completed. And here's our table in here. We've got all our total charges, monthly charges, all that good stuff all ready to go for us. Next, I'm going to import some modules. In this case, we're going to be using a module or a library called MLflow. MLflow is a module that tracks the accuracy and how we train our machine learning model. The other thing we're going to be using is sklearn, scikit learn, which is a machine learning library that allows us to quickly write train models. Typically, they are more tabular models as opposed to other kinds of machine learning models, things like vision and models and stuff like that. From there, we're going to do a couple things real quick. So we're going to run this to make sure all our modules are loaded for us. And we're going to make sure that our senior citizen, it already looks like it has been correctly grabbed as that object, but we're just going to make sure because otherwise it makes some of the later code more difficult for us. Now is a big piece of code I'm going to be dumping in here, and I will do my best to explain it pretty rapidly. And if you have questions, please let me know. Okay, so basically what we're doing here is we're going to split our variables. So you can think of each of these columns as a different variable in the process. What we're going to be doing is splitting all of these variables into either continuous variables, and a continuous variable, you can look at monthly charges or total charges. These are continuous. There's anywhere from 0 all the way through to 3,000, 4,000, 10,000, whatever it is. And there's a full range of variables, and you can't really split it easily into a group of set categories. Other variables in here, let's look at something like, does the person have a streaming movie service? That's easy to split it into a category. It's just a yes or a no. It's a 0 or a 1. Contract also is a categorical variable. Is it one? Are they on a 1-year contract? Do they not have a contract? Are they on a 2-year contract? What does that contract look like? Things like that. So we're going to be using this code here, and basically it's looking to see, hey, can I describe this column, which means can I find a range of values in this column? If I can, it's categorical. If it's not categorical, it's continuous. And then I'm also going to remove my dependent variable. Dependent variable is what we're trying to predict. So if we go over here, the churn, the yes or the no of these existing customers that we're training our model on, did they churn, yes or no? That's the dependent variable because that's what we're trying to predict. All these other ones are other variables that are going to roll up to our dependent variable. So we're going to remove the dependent variable, remove the customer ID because it doesn't really matter when we're trying to find when we're trying to get the machine learning model to find what pattern works to predict this customer churn. And then we're going to turn our categorical variables into actual categorical data types. And then we're going to return the dependent variable, the continuous variables, and the categorical variables into these variables here for us to use later on. So now you can see, okay, here's our dependent variable. Here's all of our continuous variables here, and here's all of our categorical variables. And this is important because the machine learning model will handle the continuous and the categorical variables in different ways to train the model accurately, or as accurately as possible. Again, we're going to be dumping in a bunch of code here, and I will go through it. We're going to be bringing in a few more libraries. One of them is, and actually we're just bringing in a randomization function from this, and we're bringing in a train test split function from here. And what this is doing is this is taking our data again, this data here, it's taking all of this data and it is randomly splitting it for us into two groups. One group is going to be what we train our model on, and the other group is what we're going to be testing our trained model on. And in this way, we can determine how accurate our model is. So if we just trained our model on the entire data set, then there'd be no real way for us to later test this model in a real world scenario without putting in real world data. And if we did that, it would be hard to know whether we were right or not. Because in this case, when we split it and our testing data, the data that we're going to score our model on, we know if that customer churned or didn't. And so we can hide that from the model, get the model to make the predictions, and then check our predictions against what actually happened and say, hey, we were right 80% of the time. That's not bad. Or we were right 99% of the time. That's amazing and probably never going to happen. But we can give ourselves a score such that when we show people our results on real world data, we can say, hey, in our testing scenarios, this showed 80% or 90% accuracy. So we're just going to do that. And this is going to give us our training data frame. So the data we're going to be training on and our validation, our testing data frame. Again, bit of code. I will explain it as usual. This indentation is getting broken here. Okay. What we are doing here is now that we've split our initial data frame into our testing and training, our training and our testing. Now we're going to split it again such that we have our variables, our categorical and continuous variables, and our dependent variable, what we're trying to predict. So that's all we're doing here is just splitting it into those two groupings. And one more step before we actually get into training a model we have to go through is we need to take all of our categorical variables and turn them into numbers. As you probably know, computers don't understand words very well, although they're getting much better at it with generative AI. But under the hood, what's always happening in a computer is looking at zeros and ones at the most base layer. And so what this is going to do, and I'll be able to show as we go through this, now you can see things like yes and no's have been converted to zeros and ones. Online security, 0, 1, and 2. And if we go back up to our initial, we can look at online security. Where's online security? So online security has yeses, has no's, and there's probably some unknowns or something like that in here that would be the third grouping. Or internet service might be a better one to look at here, where it's got DSL, fiber optic, and probably none as a third one. So basically we're taking all of these and we're flipping them into numbers to make it easier for the machine learning model to use. And the continuous variables, they actually remain in their normal number setup. Cool. We are about to train our first machine learning model. Are there any questions on what I've done so far before we go and actually create a decision tree model?
Yeah, no question. You can go.
Cool. A decision tree is pretty much what it sounds like. It is looking at these variables and is trying to determine where do I split this data into various arms of this tree in order to make a model that can create predictions for me. And what we're going to do first is I'm going to train this, and this is going to look like nothing. It's just going to give us, just going to say, hey, I'm done. And to make this a little bit more relatable as to what it's doing under the hood, I'm going to then plot what this tree actually looks like. So we're going to actually visualize what this initial tree looks like. And we're limiting ourselves to 4 leaf nodes. A leaf node is an end piece of the tree. And so what we're going to do here is I'm going to paste in here. I'm just going to grab this plot tree function, and I'm going to go plot our tree. M is the tree that we just created here, and we fit that tree to our training data. So our categorical and continuous variables and our dependent variable. And the other thing we're doing is we're just taking the column names and making sure that when this tree is plotted, it actually shows which columns it's splitting on. Now we can actually see what this tree looks like. There's 4 leaf nodes, 1, 2, 3, 4 leaf nodes. And what this is saying to us is, hey, based off of this initial model we've created up here, contract, if someone has less than 25 on a contract, meaning probably means they do not have a contract, it's pretty likely that they're going to churn. If they don't have a contract and they don't have online security, they're pretty likely to churn. If they don't have a contract, they don't have online security, and they don't have much tenure, they haven't been a customer for very long, they're probably going to churn. If they have a contract, they have online security, they have been with us for a long time, they're less likely to churn. That's what this model is trying to explain to us here. There's a whole bunch of Ginny things and stuff like that. I'm not going to dive into that too much because that's a course in its own. But just to give you an idea of what this decision tree that we've created, and decision trees are probably the most popular way and the most capable way of creating machine learning models on tabular data sets. So again, I'm not talking about vision data sets or image machine learning models. Just we work with mostly in Fabric is probably going to be tabular data. So that's why I'm trying to show off this decision tree classifier. And so right away, we've actually got a machine learning model created. We've been able to plot what it looks like. This is also telling us what are the most important columns really in the data to find for the machine learning model to find patterns. And what we're going to do quickly here is we're going to find based off of our machine learning model was created on what was created with the letter M, or M is our machine learning model. And we're going to run predictions from our machine learning model on our validation, continuous and categorical columns. We're going to compare that back to our dependent variable, whether that customer actually churned or not from our testing data set. And we're going to find out what's the error. How far off are we with our predictions? And what we're going to see here is we're about 23% wrong, which isn't that bad. That means, what are we? We're about 7% correct. So we have got a model here that's about 77% accurate, which all in all isn't too bad to start, but we can probably get better. And how do we get better? There's a couple ways we can get better. The first way we can try is right now, our initial machine learning model, we had at 4 leaf nodes. We told this machine learning model, you can go and come up with 4 ending points. That's it. Don't make a tree bigger than this. We want a small, tiny tree. And here, what I'm saying is, hey, let's take that. Let's go 8 leaf nodes. What does that look like then? Is that going to be a better one? Is that going to be a worse one? Interestingly, sometimes it's worse. Sometimes it's better. What you really need to do is keep running tests. And that's what machine learning creation is all about, is running tests and finding out what works and what doesn't. So now we've created a tree that has 8 endpoints. 1, 2, 3, 4, 5, 6, 7, 8. And you can start to see that more variables are actually getting used here. So again, it's looking at contract. If they don't have a contract, they're probably going to churn. If they do have a contract and they don't have online security, monthly charges are more than this, they're probably going to churn. If they don't have a contract, if they do have a contract, they do have online security, they have been with us a long time, they don't have internet service, they're not likely to churn. So there's, again, this tree that we've created, that's what that tree looks like. And then again, we can go and test, hey, this new tree we created, which has 8 leaf nodes, and we've applied it to that M variable again. So we've overwritten our initial tree. We can now go and say, what's the error on this new tree? It's 21% now. So now we're up to a 78, 79% accuracy rate. That's cool. We're getting better here. More leaf nodes, better results. And that's typically what you would find. Although you will hit a ceiling at some point. And so there's an idea in machine learning. I'm just going to paste this code in here and then I will explain it. There's a idea in machine learning, and this is standard across a lot of different machine learning techniques. But now you can see I'm not using a decision tree anymore. Now I'm looking at this thing called a random forest. What's a random forest? Interestingly enough, a random forest is, let's start with the word forest. A forest is a bunch of trees. So instead of just looking at one tree, we're going to create a forest of trees, and we're going to create 100 trees. And each of those trees is going to have at least 5 leaves. So we can say, not that before we were saying we want a max of 8 leaves. In this case, we want to say for every single of these 100 trees, you have to have at least 5 leaves. And we're going to randomize these trees, which means that we're not going to give every tree the same set of columns. We're going to hide the contract column from some of these trees, and we're going to hide the tenure from some of these trees. And so we're going to give it a random set of the variables to each of those 100 trees. And what you'll find is the more trees and the more leaves, and you take all of those trees and you average the results out, you get better accuracy on your predictions. So you end up creating a better model by having a whole bunch of models and finding out what's the average of those models. And that's something they do a lot now if you look at polling in politics, which isn't very accurate, but some of those polling systems in politics now, they don't only look at a single poll, they take an average of a whole bunch of polls, knowing that most of the polls are going to be wrong. But if you take the average of a lot of wrong things, you end up getting something closer to the truth. And that's what we're doing here. We are now going to run our random forest classifier. So we're going to create our forest of 100 trees. And that's done. And just an interesting thing we can do here, and we're not going to be able to visualize all 100 trees because it would just look impossible to actually look at. So what we are going to do is we're going to look at the first 5 trees. I think I put it here. So yeah, we're going to say, hey, let's take a look at 5 trees here. And let's see what those trees, we're going to plot each of those trees. What do those trees look like? And again, you're probably not going to be able to see what it actually looks like because it's going to be a bit of a mess, but you can start to get an idea of what these trees look like at a high level. So we're going to let that run. While that runs, also going to get ready for us to, again, take our random forest because we've now named our model. We've assigned our model to the RF variable, random forest variable, and we'll get ready to find out, hey, is this approach here where we get 100 trees, is this going to give us better than 21% error? So a 79% accuracy. This here is probably, that might take a while. We'll have to see if we can let that run or we have to stop it. While we wait for that thing to go, are there any, oh, there we go. Cool. So you can see, because I said up here that the minimum leaves is 5, it's actually creating these big giant trees. And because we've hidden certain columns and allowed other columns, each tree looks fairly different. And so we've got our 1, 2, 3, our 5 trees lined up here. And you can understand, because I said we're actually going to create 100 trees, there's actually 100 trees that have been created in the background, and I've just visualized the first 5 of them. So there's 100 trees looking like this that are all trying to figure out whether that customer is going to churn or not for us. And we can see here, we're now down to 19.8% error. So we're up to almost an 80.2% accuracy rate now on our tree. So we've gone from 78 all the way to 82. And what you'll see is once you create the first model, your improvements in accuracy are going to get smaller and smaller as you get more complex, but you will be able to drive some additional accuracy out of bigger and more capable models. But you're probably not going to see a jump where you're like, hey, I'm at 80% here and now I'm at 99% over there. That's just not the way these things typically work. Cool. Next, we're going to do something. We're going to save this model, or we're going to start to save this model, and we're going to, let me just fix that up. So what I said at the beginning was MLflow allows us to track our models. And I'm telling MLflow, hey, we're using this scikit learn library to do our model. I want you to log all the details you can from this next training run that we're going to do. And I want you to pay attention when I run this training run, this code, almost the same as this, as this code up here. There's a couple things. I've increased the size of the forest to 1,000 now. So we're going to do 1,000 trees under the hood. It won't take much longer. And we're doing it within this MLflow start run, which will save all of our accuracy details and a whole bunch of our details around the training data into the machine learning model we created, this ML churn model that I'll go back to after. And what that means is when we run our next model, when we continue to try and iterate on our model and make it better and better, we'll be able to look back and say, hey, we started with this model here, which was this good, and now we're up to this model version 5, and it's this good, and now we're up to version 10, and it's that good. And we'll be able to see, hey, is our work helping us get better, or is it making us worse, or is it just standing still? And what does that look like? So we're going to run this. Don't worry about the warning there. Excuse me. And it has run, again, finished 14 seconds. And we now have a random forest with 1,000 nodes. And it's also going to try there. It's at 19.6% error now. Before we were 19.8%. So we've gained a few percentage points. Not really, but a little bit. We've trained our model. Now we're going to jump back to our workspace just to make sure we're clear on what's been happening under the hood so far. We initially created our ML model, and this is in a Fabric workspace that we're in, just a standard Fabric workspace. We created our ML model. Our ML model then created this notebook. And as we were running our experiments, this notebook was creating this experiment area for us. Click on our experiment, and we can see all of those various runs we did. The last one is the one that we actually caught all of our metrics for. So we got a whole bunch of information. It knows what kind of machine learning model we did. It knows what the input looks like. It knows what the output should look like. It knows our accuracy scores, our loss, our mean absolute errors, what we were tracking there, which is that 19.6. And we like this one. We're going to save it. We're going to say, yeah, let's save this. And we're going to save it to our ML churn model that we had created initially. And we're going to save the model folder. I'll show you that in a sec. If you open this up, the model folder is just this, and this is what actually contains our model inside of it. This is our machine learning model here, saved as a, I don't know why, but it's saved as a pickle format. There, and that has been saved. So if we click back to our machine learning model and refresh our browser window, we now can see our machine learning model has this initial experiment in it, and we have a V1 of our machine learning model. I think we only got 5 minutes left. I'm not 100% sure we're going to be able to do our load and predict piece on real data. And really what it is, we're going to be, so there's a couple ways. We can bring our model information through to Power BI. What we're going to be doing in the next session is actually taking ideally I would have time to run this load and predict stuff where we'd actually make our prediction on data and save it and then we'd be able to visualize whether whether we've predicted a customer is going to churn or not. That would be the ideal next step, and that's what we're going to try and do in our next session. The other thing you could look at is wanting to actually visualize the accuracy of the ML model and things like that. And that's something we will try and look at next week. I don't know if we'll have full time to do that, but again, it'll be one of those things we'll do our best on. Cool. So I'm going to go and just paste some code in here. A lot of this code is actually code that we've already gone over just to get data into a format that we need it in to do some testing or to do some predictions on. And ideally you would do this with new data. I'm just reusing the same data we trained this model on. Ideally you would have this same customer data in your ERP or CRM that you'd be able to then use on new data to make predictions based off of your actual business data. And I'm going to keep pasting code in here while the code is running to see if we can get there in time or not. But didn't like that. Data frame df.two pandas. Ah, yes. I spelled that wrong. See if that works. And let's do this. Doesn't like this. What am I doing wrong? df cats 13. That should be okay. That one worked. This was just resetting up the data. It's almost the exact same code I explained before. This is the interesting piece of code where we are actually taking our model, and our model name, I believe, is actually ML churn, and it's version 1 of ML churn. These are our input columns, and then we are taking that model that we had saved before. So the nice thing is that old notebook that we had where you have to run everything at once. This one, if you had your data, you could actually, we're going to download that model from the ML model we saved, this one here. We're going to download that model. We're going to then take our data that we're recleaning back up here, and we're going to run this transform, which is the same as running a prediction. So we're just going to run our model and predict data off of it. Up here, we've stripped away the churn and things like that. Again, usually this would be data that doesn't have a churn variable yet because it's just new data that your model hasn't seen yet. In this case, we're just faking it. But yeah, we'll run this. And you can see now we're downloading our saved model. Running there. And it's currently now running our predictions on the data that we had cleaned up here. This will take a minute or two. We've got our customer ID now. So we've kept the customer ID in place. We had all of this information that we had converted into these category codes with all of this. And this churn field is actually now our prediction of whether this customer is going to churn or not based off of our machine learning model's pattern that is created. Now, one thing that we're going to want to do here is if we look at payment method, it might not make sense for a human to look at this and be like, oh yes, payment method number 2. I know what that is. So we're going to flip all of those back into what they actually are. So now we flip them back into the words. So you got your 1 year, 2 year, month-to-month contracts. You got your different payment methods all back in its correct form. And then in a lot of cases, you might just want to say, hey, I just want to know the customer ID and whether they churned or not. And now we can look at this nice and easily and say, okay, this customer ID, I predict they are going to churn. This customer, I don't think they're going to churn. And in this way, you'd be able to then run this on a daily, monthly basis, whatever you're looking at. Take your model that you know has 80-something% accuracy and run that against your new data in your CRM and figure out, is this person going to churn or not? And then you can, again, next time we will try and visualize that data to show in a prediction format, which customers are going to churn, and we can then do things like send that along to a sales team to say, hey, here's the customers today that we predict, or this month that we predict may churn in the next few months. Go follow up with them, see how they're doing. They might need a little extra love there. That kind of brings me to the end of our scheduled programming for today. Happy to stay on the line for any final questions.
Thank you for this great session, and thank you for everyone to join.